So we've been asked for vertical and horizontal asymptotes. The first is a rational graph, which will generally look like this. And so it could have both a horizontal and a vertical. So for our rational graphs, our vertical asymptotes come from 0 in the denominator, so I better factor both the numerator and the denominator. So we have x times x minus 5 in the denominator, x minus 2 times x plus 2 in the numerator. And so the vertical asymptotes appear to be x equals 0 and x equals 5. But I have to make sure there's no holes, because if I ever have the same factor, numerator and denominator, that would be a hole, not a vertical asymptote. But since I don't have either x or x minus 5 in the numerator, then I have two vertical asymptotes. So here my vertical asymptotes are x equals 5 and x equals 0. Now to find the horizontal asymptote, I have to look to see, just looking at the leading term, what does this simplify to? Well, this simplifies to x squared over x squared, because I'm going to ignore the minus 4 and the minus 5x. And when I put a really big number in, because I'm looking for horizontal asymptotes, way over here as x approaches infinity and x approaches negative infinity, if I have 100 squared over 100 squared, that simplifies to just 1. That's why I can ignore the negative 4 and the negative 5x, because when x gets big enough, then I don't care about those other two things. And so my vertical asymptote would be 1. So y equals 1 for the vertical asymptotes, and x equals 5 and x equals 0 for my horizontal asymptotes. Now I'll look at the log graph. We recall a log graph looks like this. So I'm only searching for vertical asymptotes, and they come from our shift. So if I let 2x plus 8 equal 0, that means I'm going to have 2x equals negative 8 and x equals negative 4. That's my horizontal asymptote. What's really happening is I'm shifting this 4 to the left. And so for this last one, an exponential graph looks generally what I've drawn here in blue. This means I double, and this means that my y-intercept is 5. So this might be a 5, and I'd be doubling every time. This last piece, minus 3, means everything that you see here is going to come down 3. And so it's going to look like this, with a new horizontal asymptote of y equals negative 3. So that would be the asymptote for the last one.